All right, today I wanted to walk you through how to do a repeated measures ANOVA. So what I've created here is just a Scratch data set to demonstrate this. And the Scratch data set has just a few basic elements. First of all, we have over on the left our experimental condition. In other words, in this data set, 25 people got the control condition and 25 people got the intervention. This is a basic two-group experiment. However, what we wanted to know was not just what were their final scores on the post-test, but we happened to gather both pre-test and post-test scores. The nice part about doing this is we gain a lot of statistical power because now every person acts as a control against themselves. You guys may remember this from research methods and statistics. So for instance here, this control, we see that they scored a 2 on the post-test, but that's actually pretty close to what they scored in the pre-test. Not much of a change. Here, this person went from a 2 up to a 4, a positive change of 2. And this person went from a 3 to a 6, positive change of 3. If we go down here to the intervention, we see some of these people went just a change of 1, 5 to 6, 6 to 8, change of 2, 7 to 10, but some of them jumped way up from a 1 to a 6, positive change of 5, and a 2 to an 8, positive change of 6. So all that to say, we get to take a look at change scores, and that's what we want to do in a repeated measure, ANOVA. So how do we go about analyzing it? What I want you to do is open up, if I were you, I would actually open up this file in JASP, and what I've done is I've saved it for you in the OSF. I will make a separate video on how to retrieve files from the OSF. But for right now, what you can do is to click on Repeated Measures ANOVA. Okay, Repeated Measures ANOVA has a few key elements to it. First of all, it wants to know what is our main factor that we're looking at. And for us, this is, we could call this a few things. What I like to do is to label this whatever my outcome is. So my pre-test and post-test, let's say that they are measuring ability to think of creative names, which I obviously don't have. So I'm just going to call it ability to think of creative names. My level 1, I'm going to call this the pretest. And let's imagine I did an amazing intervention where I tried to create different opportunities for people to think of creative names. And then I wanted to see at the very end of it, how good are they in the post-test at thinking of creative variable names? Hopefully better than I was. So this is my main measure. And I have both a pre-test and a post-test. These are my two different levels of people's ability to think of creative names. So if I go back and take a look at the numbers, that's in fact what these numbers mean. This person has a very low ability to think of creative names and doesn't improve much. This person has a relatively low ability but improves significantly more. People down here may have low abilities, but they improve drastically. So all that to say, when we take a look at our variable names, this is what we're thinking of. Now what we have to do is to define for JASP, okay, where are we getting our data on the pretest? Luckily, I've labeled this pretest. That's what I call my variable. Although in other data sets, you may see this as time 1, and the other one is time 2, or time 3, or time 4. So you need to figure out what my time 1 or my early variable is. Then, if this is a longitudinal study, which this one is, I want to figure out what my post-test is. Here I've labeled it before. Now, the third and final element that we have here is how are these subjects different from one another? So remember, in our data set over here, I had given some of these people a name control, which meant they got the control condition. Other people got the intervention or the experimental condition. This is how they differ between participants. Over here, this is the within participants variable because every person takes a pretest and a post-test. Here, some people are controls, some are interventions. That's a between subjects difference or factor. So I'm going to take my experimental condition, and that's whatever manipulation you're giving usually. And I'm going to put that into the between subject factors. Now, the nice part about JASP is immediately we start to see the statistics show up here to the right. So the great part is we see there is a basic change over time. So if you average everyone across these groups, on average, everyone seems to be changing on their ability to think of creative names. But it looks like the experimental condition makes a difference. In other words, there's an interaction between the experimental condition and this ability. We know that because this P is less than 0.05. But it's a little bit tough to tell what's going on, so we're going to choose a few more options to get a better sense of what's actually happening. First of all, we're going to click on Descriptive Statistics, because what this lets us do is to actually see how are these people changing. And so what we see here is from pre-test to post-test, the control group gets slightly better in their ability to think of names. They go from 3.7 to 3.9. The intervention group appears to get more better. They go from 4.1 to 7.9. So we start to get a sense that maybe this intervention group is improving more from pre-test to post-test. And when we take a look up here, that seems to be the case. But we'll do a few more things so we get an even better idea. One of them is just to give us a diagram of what this looks like. So what we want to do is to take whatever factor they're being measured on. So here, I've labeled that ability to think of creative names. We're going to put that on the horizontal axis. Because what this will means is along the bottom on the x-axis, we'll see pre-test and post-test show up on the left and the right of a graph. And then we'll have our separate lines be the two different experimental conditions. And what we get is a relatively, that looks strange actually. Let's let that refresh. Because we should have two lines on there. There it is. All right, perfect. So now what we see is, indeed, in this control condition, people don't seem to be changing very much in their ability to think of creative names. But in the intervention condition, it looks like they change much more. Okay? We're going to look at two additional ways to examine this. One of them is the post hoc test. And so what we're going to do is to add in, because there was a significant interaction, we just want to do post hoc tests on the interaction. The way you can tell it's an interaction is this asterisk in the middle. Or the way you'd read that is experimental condition by ability to think of creative names. In other words, we have one factor, the experimental condition, that's moderating how the ability to think of creative names changes over time. In other words, if you ask, do people just get better at the names? Well, you say it depends. It depends on if they're in the control group, in which case it doesn't look like it, or the experimental group, in which case it does look like it. Okay, so we're going to take a look at those post hoc tests, and sure enough, what we find is, although there's no difference between the control pre-test and the control post-test, this is the mean difference, and it looks like our P is 1.0, in other words, not significant. When we look at our intervention pre-test and our intervention post-test, we do see a significant difference. So it looks like this point is different from this point. So they made a change here. One other way to say that is, although these 2 points don't differ at the beginning, that's the control pretest and intervention pretest, they do not significantly differ. In the post-test, the control post-test and the intervention post-test do differ. Those are two different ways of describing the exact same thing. In other words, we see a significant change for the intervention, but not for the control group. Or we see at post-test, these two groups are different, whereas in the beginning, they weren't. I tend to prefer, I think the change score makes more logical sense. I think that's the better analysis to use. Okay, One last analysis that I want to show you how to do, which is the contrast. So because we had a significant interaction, what we want to do is to take a look at whether or not those lines are different. So is the slope of this line different from the slope of this line? And what we find is, because we only have two variables, we can only look at this first comparison, and we find, sure enough, it is. That p is less than 0.001. And this is a nice, powerful way to examine the difference in the slopes of the lines. So what we have here are a few different ways to examine repeated measures data. What I want you to do is to try to use the data set that I've given you, or your own data set, to figure out how to do this. And to do that, you'll have to identify which of the variables in there are the experimental conditions, what is the pre-test for one variable and the post-test for one variable, and then how would you go about labeling it in the system. Well, what I want you to do is to add everything in here. Make sure you have descriptive statistics. It's actually helpful to do estimates of effect size. And what that does is it gives you, off to the right here in a second, a general idea of how big these differences are using standard deviations. Then you want to look at polynomial contrasts on the interaction term. That's the third one down there. You want to do post hoc tests on the interaction term. And you want to plot the descriptives. And you want whatever your pre-test, post-test variable is to be on the bottom on the horizontal axis, and separate lines for your experimental conditions. All right, work together, enjoy, have fun playing with statistics.